Before we start the lecture this afternoon, I thought you might like to know a little bit more about how your online lectures are actually produced. Most of the time I use an Apple iPad Pro, the 12.9-inch version, and the beauty of using the iPad Pro is you get a lovely big screen to work on, and you can probably see with the Apple Pencil you get a very nice flow of the writing on the screen, and it's very easy to change colours, to change the thickness of the lines, to draw straight lines and so on. Really nice using this, and the quality that you get in terms of the slides, it looks just like someone's writing in real time, but you don't see their body and you don't see their hands in the way. You just hear the voiceover narration explaining what's going on as the slide develops. It's not unusual for me to record it 4 or 5 times before I'm happy with what I've done on the iPad Pro, and even then I'll still transfer it onto an Alienware laptop where I'll do the video editing. And usually when I do the editing, I'll cut out bits where I feel as though I've explained too much and maybe there's a little bit too much there, it needs to be trimmed down a bit, or if I've made a mistake and I want to cut it out, and sometimes I even notice mistakes which I didn't notice before, and I then have to go back and re-record part or all of the video again. A great thing about the online lectures is you can study them whenever you want and wherever you want. And it's the same for me as a tutor when I make them. It's a beautiful summer evening here in Astana with a fantastic view out over the western steps of the horizon from the 23rd floor. So let's pull a chair up by the window and we'll make the final part of this lecture. In the last part of the lecture, we'll look at inverse functions. An inverse function does the opposite to the original function. Or in other words, inverses undo what the function does. If a function tells you to do a certain thing to x, applying the inverse will take us back to the start. If, for example, the function was +1, the inverse would be -1. If the function were multiply by 2, the inverse would be divide by 2. The inverse function has a special notation. It's written as f to the -1 of x. A function maps an element in the domain to an element in the range, but the inverse function maps an element in the range to an element in the domain. It does the opposite of a function. It undoes the mapping. But what this means is that only one-to-one functions have inverses, as the inverse of a many-to-one function would be one-to-many, and that's not a function. It would not pass the vertical line test. And this is illustrated nicely by the two figures. In the first figure on the left, f of x is 1-to-1, and it's illustrated by the white curve. When we find the inverse, we get another one-to-one function. In the figure on the right, the original function f of x is many-to-one, but when we try to find the inverse of this, we'll get one-to-many, and that's not a function because you can see this green curve would not pass the vertical line test. The order in which we apply the inverse and the original function doesn't matter. If we apply f to the -1 of x on f of x, it's the same as finding f of f to the -1 of x, which will give us x. And it's really important to remember that the domain of the inverse function, f to the -1 of x, is the range of the original function f of x. The range of the inverse function f to the -1 of x is the domain of f of x. And these facts help to make it easy for us when we're working with problems involving inverse functions. Let's have a look at an example then. We have f of x is equal to x plus 7. The domain is x is greater than or equal to 0, and the range is greater than or equal to 7. Does this function have an inverse? And if so, state the domain and the range. Well, the answer to the first question is definitely yes. It's a one-to-one function. And because it's one-to-one, it will have an inverse. So how about the domain and range? Well, as we said on the previous slide, the domain of the inverse is the range of the original function. So the domain of the inverse function will be f to the minus 1 of x. Domain is x is greater than or equal to 7. The domain of the inverse is the same as the range of the original function. F to the minus 1 of x has a range greater than or equal to 0. So just using those basic facts, we know that the inverse function has a domain corresponding to the range of the original function, and the inverse function has a range corresponding to the domain of the original function. Let's have a look at another example then. The function in this example is a little bit more complicated than what we dealt with before. We're given f of x is equal to the square root of 2x minus 1. The domain is x is greater than or equal to a half, and the range of fx is greater than or equal to 0. We want to find the inverse function f to the minus 1 of x and state the domain and the range. So we need a strategy for solving problems like this. And I'll take you through this step by step. So we'll begin by writing f of x is equal to the square root of 2x minus 1. The first step is to replace f of x with y. So we'll write y is equal to the square root of 2x minus 1. And let's just make a note of that. Replace f of x with y. The next step is to square both sides, so we can remove the root. Y squared is equal to 2x minus 1. Now we'll rearrange to make x the subject. We'll make a note of that. Make x the subject. The next step is to replace x with f to the minus 1 of x and replace y with x. So we can write this as f to the minus 1 of x is equal to x squared plus 1 over 2. We'll make a note of that. Replace x with f to the minus 1 of x and replace y with x. We now have our inverse function. F to the minus 1 of x is equal to x squared plus 1 all over 2. The domain of the inverse is going to be x is greater than or equal to 0. And the range will be f to the minus 1 of x is greater than or equal to a half. So all we've had to do there is swap around the domain and the range from the original function. Let's have a look at a similar problem. We're given f of x is equal to 3x squared plus 2. The domain is x is greater than or equal to 0, and we want to find the inverse function, f to the minus 1 of x, stating the domain and the range. We'll proceed in a similar manner to how we did before. So we'll write f of x is equal to 3x squared plus 2. The first step then is to replace f of x with y, and we'll write this as y is equal to 3x squared plus 2. We're then going to rearrange to make x the subject, and after a little bit of manipulation we can show that x is equal to the square root of y minus 2 over 3. We don't need to consider the negative square root because the condition is that x is greater than or equal to 0. Finally then, we replace x with f to the minus 1 of x and y with x. So we can rewrite this as f to the minus 1 of x is equal to the square root of x minus 2 over 3. The range of f of x is greater than or equal to 2. So f to the minus 1 of x has a domain of x greater than or equal to 2. So for f to the minus 1 of x, the domain will be x is greater than or equal to 2. The domain of f of x is greater than or equal to 0. So the inverse is going to have the range f to the minus 1 of x is greater than or equal to 0. So again, we've just interchanged the domain and the range compared to the original function. In the final example, we'll sketch the function f of x is equal to x squared minus 8 on the domain x is greater than or equal to 0. We'll use this to sketch the graph of f to the minus 1 of x, and we'll find the domain and range of the inverse function. X squared minus 8 is going to cut the y-axis at negative 8, and it'll cut the x-axis at 2 root 2. We'll mark that on there. Of course, it's going to be a parabola, so its shape is going to be something like this. Given some function f of x, if we can sketch the function, it's very easy to sketch the inverse, because the inverse is a reflection in the line y equals x. We'll put that on the graph. Y equals x. We now have to imagine what the function will look like when it's reflected in this line. We should be able to see that it's going to cut the x-axis at minus 8, and it will cut the y-axis at 2 root 2. So let's see if we can sketch that. So there's our inverse function f to the minus 1 of x. All that remains is to write down the domain and the range for the inverse function. We can see that the domain of the inverse function f to the minus 1 of x must be greater than or equal to minus 8. So f to the minus 1 of x has a domain of x is greater than or equal to minus 8. And the range of f to the minus 1 of x is going to be greater than or equal to 0. Now have a go at the multiple choice question.